Okay, so another problem with a rational function. So when we see this rational function, we're going to want to factor the numerator and factor the denominator. You can do that right at the beginning. That's not a bad idea in case there are any holes, anything cancels. The numerator factors into x minus 3 and x minus 1. So you think about the factoring. And then down in the denominator, you can factor out a 2, and you're going to have 2 times x squared minus 4, but then that's the difference of squares. So x plus 2 and x minus 2. So that's how it factors. Now, when you want to find the horizontal asymptotes, that had to do with like when the degree of the numerator and the degree of the denominator. Well, when they're the same, when n equals m, you have like n greater than m, n less than m, n equals m, and they might be the other way around, but it doesn't matter. It's the top one that you're looking at compared to the bottom one, the degrees. This time they're the same, and so you use the coefficients. There's a 1 here and a 2 here, and that is your horizontal asymptote. Y equals 1 over 2. So y equals 1/2. That's going to be a vertical line at 1/2. Sorry, a horizontal line at 1/2. Okay, so that's the horizontal asymptote. So you have to consider on your note page when if n is the numerator, n is greater than m, then it's y equals 0. And if n is less than m, there's no horizontal asymptote. And that's when you have a x to the nth over b x to the m. Okay, and then there's more to the polynomial, but that'll get you started on that. Okay, so you can go back and look at the video on that, but it'll be from rational functions and how we graph them. It has to do with horizontal asymptotes. Okay, so that's that part. This is the answer for what I put a box around. The other stuff is just information for you. Okay, now it says find the x-intercepts. The x-intercepts come from the numerator. When does x minus 3 times x minus 1, when does that equal 0? And we've done this before. Okay, so we're going to have two x-intercepts this time. 0, 3. I'm sorry, I did it the wrong way. 3, 0. And 1, 0. All right, that's the answer. Now, you might be saying, hey, what about that x plus 2 and x minus 2? I was all set to do something with that. Those would be the vertical asymptotes, would come from there. This question didn't ask about that, but I'll just go over it. You'd have one at x equals negative 2 and one at x equals 2. So I could have asked what are the vertical asymptotes, but that question wasn't on there. Okay. Solve the polynomial inequality. Okay, this is an inequality. Please, please, please do it the way I'm telling you how to do it so I can see your work and it will all make sense. All the time I'm getting students doing this problem a different way and the work does not make the answer. Okay, it might in your mind, and it might online, but it's not showing how to get the answer. Okay, so please follow the directions. Okay, it's already factored for you. That's good news. Okay, so make a number line. And you're looking for these critical values. Always put 0 on the number line, please. Your one critical value is going to come from this factor at negative 3. Okay, so you're looking when does the factor equal 0? And the other one's going to come from here at 5. Okay, we do not want it to equal 0. We want it to be greater than or equal to 0. So we will not be using those. I put a little dotted line to say, hey, we're not going to actually include it. It just has to do with whether you use a parenthesis or a bracket. Okay. Now we're going to do test points. So test points. And we're going to be testing to see if x plus 3 is times x minus 5, if that is greater than 0. If it is, then it's part of the solution set. If it's not, then it's not. Okay. So you have to pick a point in each section. So maybe I want to pick like negative 4. I need a number smaller than negative 3. It can be any number smaller than negative 3. But what happens then is this becomes a negative factor. You can put -1 if you want, because -4 plus 3 is -1. And then this is also negative. Turns out to be -9. But it doesn't matter what the number is. The fact is negative times negative is positive, and that is greater than 0. So yes, yes, this section works. Smiley face, yes. Something that says, I want that section. Okay, now pick a number between -3 and 5. I usually pick 0 if it's in there, but you can pick 1 or whatever. That makes this positive, actually a 3, but it doesn't, again, it just matters if it's positive or negative. This is going to be a -5. So I have a positive times a negative. Is that greater than 0? No, because that's negative. A positive times negative is negative. That's why we set these to 0, okay? Because we want to know positive or negative, and then that makes it much easier for us. No. Okay, now pick a number bigger than 5. A lot of times students will pick 6. That gets you a positive here, get you a 9, but it doesn't matter that it's 9. And it gets you a positive 1 here. Positive times positive, is that greater than 0? Yes, positive times positive is greater than 0. Okay, this is the work I expect to see on your test. Okay, I don't expect to see some other crazy stuff. Please make sure your work shows this information. Okay, let me emphasize that. Okay, so now we have to write the answer though in interval notation. Remember, interval notation, you have to go left to right. So if you get it backwards, I'm going to take off for that. So we're going from -infinity to -3. We're not including the -3. That's why it's a parenthesis. Remember, infinity and -infinity always get a parenthesis. And then we have to skip over that section between -3 and 5. So we put a union. And then we pick up at 5, parenthesis 5. Again, we're not including 5. And to infinity. And so that's going to be the answer. If, this is pretend now, if that had been greater than or equal to, you would have had a bracket at -3 and a bracket at 5. Okay, that's not the case here, but I'm just saying if it had been greater than or equal to. Okay, because a lot of times students are like, well, what if? Okay, so now we have one of our variation problems. So these are in 3.7. The distance that a spring will stretch varies directly. Those are the words you're looking for. So distance, I'm just going to use D for distance. You can use whatever letter you like, but it's best to use something that makes some sense. You have to have a K, and it varies directly as the force. I just use a capital F for force, but again, you could use probably a lowercase f. Okay, that's the relationship. Distance varies directly as the force applied to the spring. Okay, a force of 12 pounds. So that means your F is 12. Is needed to stretch a spring 9 inches. The distance then is 9. Okay, so this allows us to find K. Divide by 12, divide by 12. Simplify that 9/12. And it's going to be 3 over 4. You could put 0.75 if you wanted to, but I just used a fraction. Fractions are cool. All right. So what that means is now you know that constant, that value of K. That's great. Now we have a new equation. This is like a formula we can use. If they tell us the distance, we can find the force. If they tell us the force, we can find the distance. Great. So what's the question? It says what force, okay, so I'm looking for F, is required to stretch the spring 15 inches. That 15 is the D, right? So that's your equation. Now you want to solve. I would multiply by 4/3, the reciprocal. Just a little fraction work. If you used a decimal, you would have divided by the decimal. That would have worked. 3 goes into 15 5 times. 4 times 5 is 20. Now, the one thing though I do want you to do is make sure you put the units. So that's 20 pounds. Force was being measured in pounds. Okay, or you could write out the word pounds. Okay, so that's the answer. The force required to stretch the spring 15 inches is 20 pounds.